Hello everyone. Good evening to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of mathematics at IIT Bhubaneswar. Today we are going to talk about week 12 assignment, which is basically depends upon mm, covering spaces and those things. Let us first look at the first problem. So, whether the screen is visible to everyone?
Yes, sir.
Okay, okay. So let F such that open unit disk to C be a holomorphic map, okay, such that F of 0 equals to 0, F dash 0 equals to 1, and this modulus of Fz is less than equals to 2 for all z belongs to D. Then which of the followings is less are true? So this is the first option. Second, so we will look all these options one by one. So F has the expansion z plus summation n equals to 2 to infinity a n z to the power n. Okay, so basically f of 0 is 0 here and f dash 0 is 1. Okay, so it satisfies that one. Okay. So this we can basically write it as mod of fz is greater than equals to mod z minus summation n equals to 2 to infinity a n z to the power n. Isn't it? Hello? This one is clear to everyone? This thing, what I have written? Okay. So now for option A, we know that A n we can write it as 1 upon 2 pi I, okay, and over mod z equals to r. So you take any r between 0 to 1, okay. F of w upon w to the power n plus 1 dw. So this is the an. So mod an you will get it as 1 upon 2 pi integral over mod z equals to r w to the power n plus 1 dw modulus. So this will be less than equals to 1 upon 2 pi. Okay. And since modulus of fz is less than equals to 2, so you will get 2 into modulus of z equals to r d mod dw upon r to the power n plus 1. Okay, so this basically you will get so mod an is less than equals to 2 by r to the power n. Okay, now as r goes to 1 from the negative side, okay, you will get mod an is less than equals to 2 for all n greater than equals to 2. So option 1 is correct. Okay, is it clear to everyone? Hello? Okay, now let us look at the option B. So you have given a circle z such that mod z equals to 1 by 4. Okay, now let us call this equation as A. Okay, now as we know that mod anz to the power n is basically mm, So summation a n z to the power n modulus is less than equals to summation a n mod z to the power n. Okay, and basically this will be uh, let us call this 1. So by 1 it is nothing but is less than equals to 2 into summation mod z to the power n, isn't it? So let us call this one as equation B. So by equation A and B we have, so what is A? Mode of fz, okay, and we are talking about on the circle mod z equals to 1 by 4, okay. So we will get mod fz is greater than equals to mod z minus 2 summation mod z to the power n. The summation is from n equals to 2 to infinity, okay. Now this is mod fz is greater than equals to mod z is what, 1 by 4 minus 2 into summation n equals to 2 to infinity 1 upon 4 to the power n, okay, and this will be equals to 1 by 4 minus 2 into, so 1 upon 16 upon 1 upon 1 minus, so 1 minus 1 upon 4, okay. So this you will get 1 by 4 into minus, so this you will get basically 12, so 2 upon 12, okay. After this you will get 1 upon 12 mod fz. So mod fz is greater equals to 1 by 12 for all z belongs to C. So option 2 is also true, okay. Now the third option is, it is saying given any point in the ball center at 0 with radius 1 by 12, you can find a z in ball center at 0 and radius 1 by 4 so that fz equals to w, okay. So let us see these options. Option C, okay. So let w belongs to this ball, okay. So what does it mean? Modulus of w is less than 1 by 12, okay, isn't it? Obviously, okay. And on the circle C, z such that mod z equals to 1 by 4, modulus of fz is always greater than equals to 1 by 12, okay. Now you consider the function. So you have, let any w naught say, okay. Now consider the function gz is equals to fz minus w naught, okay, clear. So modulus of gz is basically equals to modulus of fz minus, sorry, okay. So so basically modulus of w naught is modulus of fz for all z belongs to C. So by Rauch's theorem, numbers of zeros of G is equals to number of zeros of F in the ball centered at 0 and radius 1 by 4. Okay, so that is, there exists Z belongs to this ball such that Fz is equals to Fz not equals to W. Is it clear to everyone?
Yes, sir.
Okay, nice. So C option is correct. And with the help of C option, we can see this ball is contained in the image, isn't it? Okay. So with this, we can see that this ball basically contained in the image of F. Okay. Because for any point, you can get a uh, Z in this one. So the F of Z equals to W. Okay. Now we'll start covering spaces. Okay. Okay. So let us start the covering
सर
space. Yeah, yeah.
सर सर 1 मिनट ये जो सी ऑप्शन है ना वो फिर से दिखाओ ना इसमें अगर 1/4 की जगह 1/8 है so
Okay.
what we say कि z0 belongs to b 0 1/8 है
हम्म। नहीं तो
तो
अगर बेसिकली इसमें अगर देखो तो हम लोग प्रीवियस चीज का यूज कर रहे हैं। बेसिकली ये जो हमने प्रूफ किया है, ये हमने प्रूफ किया है किस सर्किल के लिए? मॉड z इक्वल्स टू 1/4 के लिए।
यस
तो 1/8 के लिए हमको देखना होगा ये चीज होल्ड हो रहा है कि नहीं।
ओके
आई थिंक नहीं होगा क्योंकि यहाँ पे इक्वेशन चेंज हो जाएगा ना, 1/8 टू द पावर n हो जाएगा, 1/8 हो जाएगा। सो समथिंग एल्स विल कम हियर।
ओके सर फिर से एक बार वो क्वेश्चंस बताओ ना
कौन सा?
ये आगे का जो था ना फर्स्ट क्वेश्चन में 2 मिनट लेट थी इसलिए
ओके ओके। So these
बोलिए सर
options, first option, you please just read the question. So so f is a holomorphic function on the unit disk with these two conditions, and modulus of fz is less than equals to 2. Then which of the following is slash are true? Okay. So basically this is the Taylor expansion of f around 0. Then this modulus of an will be less than equals to 2. Okay. B option I already mentioned and others option are here. So this is the proof of first part, first option. Okay, you have to just use the Cauchy estimate. Okay, so is it clear?
यस सर
Okay, so let us move towards the covering spaces. Okay, so so I will define the covering space in general. So the definition is like this. So if this omega is a topological space, so I will denote topological space as Ts. Okay, so then a covering space of omega is basically a pair x comma rho where x is connected, x is a connected topological space, and rho such that x to omega is a function which is continuous and onto, such that First condition is for every w belongs to omega, okay, there exists a neighborhood nw such that such that sorry such that a so this rho inverse of nw can be written as the components union of components u alpha, okay, and rho restricted over u alpha such that u alpha to nw is a homeomorphism, okay. Is it clear? This one is clear to everyone, this definition?
Yes, sir.
Okay, so if such thing happens, so we call x covering space of omega and rho covering map, okay.
Yes, sir.
Yeah, so some examples we will see, okay. So let us see f such that c star to c star basically punctured complex plane defined by f of z equals to z square. Second one is f such that c to c star defined by e to the power z covering, so basically these are the examples of covering maps. Let us see one non-example, okay. So f is a covering map, is not a covering map, okay. Third example will see it as c to c f of z is equals to z square is a covering map, is not a covering map. Oh, sorry, this is a covering map, sorry, e to the power z is a covering map, is not a covering map, okay. So basically this definition tells us something about this map, okay. So let us look at some questions regarding this. So question 1 is every open map, sorry, every covering map is an open map. So whether this is true or not, okay. So we'll see this proof. Solution. So the answer is yes. Okay. So let let u comma v subset of c open, okay. So u and v are open subsets of c, and p says that u to v is a covering map. Okay, let O be an open set in U. Okay, so what we need to show that P of O is open. So our aim is P of O is open. Okay, so basically P of O, so let P of X belongs to P of O. Okay, so that is P of X also belongs to V. Okay, so by the definition, there is a neighborhood, say NPX, such that P inverse NPX is basically union of O alpha, alpha is some index set, such that P restriction over O alpha such that O alpha to NPX is a homeomorphism. Okay, so this is the definition just. Okay, so X belongs to O alpha for some alpha, isn't it? So this X, okay, this X belongs to some O alpha, okay, for some alpha. Now observe that O alpha intersection U is O alpha intersection U is contained in O alpha is open in O alpha, isn't it? Is it clear to everyone? Please let me know if any doubt is there.
सर लास्ट स्टेप समझ में नहीं आ रहा है.
So basically O alpha intersection U, okay, so this is your U, okay, and this is O alpha, okay. So once you take the O alpha intersection U, this will be a subset of O alpha again because of the intersection only, and this is open in O alpha, isn't it? So basically any open set in O alpha, how it looks like, O alpha is subset of U, okay, basically all O alpha are open, okay. O alpha is subset of U, O alpha are components open, okay. So any subset of O alpha, if there is any subset of O alpha, so how it should look like? So it should look like O alpha intersection some open subset of U, okay. So like this, let me write A, open set in U, okay. So this will be open in O alpha, isn't it? Now similar way, O alpha intersection U itself, this is open in O alpha, isn't it? Is it clear? Okay.
यस सर.
Now you see this one, image of O alpha intersection U, okay. So where does it belongs? It belongs, it contained in P of U, sorry, P of O. Okay, so this is contained in P of O, isn't it? So here is your O, and Px belongs to Po. Okay, so is open open neighborhood of Px. Thus, P of O is open. Is it clear?
Yes, sir.
Yeah. So basically, you have so that any open set maps to open set. Thus, P is an open map. Okay. Now let us look at some other things. So can anyone tell me why this is an open neighborhood? This one is open neighborhood. Why? Because P restriction over O alpha is already homeomorphism. Okay, so P restriction over O alpha maps any open subset of O alpha to an open set. Okay, and this is an open subset of O alpha. So this whole is an open set in P of O. Okay, so that's why it is open in P of O. Okay, so far so good. Okay, so now the next thing is, so this property you can observe. Let me write it down. Every covering map is locally a homeomorphism. Is locally homeomorphism. That is, if P such that X to Y is covering, okay, if this, then for every X belongs to X, there exists some neighborhood open set Ux such that P restricted over Ux such that Ux to Pux is a homeomorphism. This comes from the definition itself. Check it. Okay, so now we will talk about something we call lifting. Okay, just check. Yeah. So definition is, let X, Y, and Z be open subset of C, open subsets of C, and let F such that Y to X and G such that Z to X be continuous maps. Okay, we say that a map G tilde to Z to Y is a lift of G with respect to F if f composition g tilde is equals to g on z. Okay, so basically you have y to x function f and z to x function g. Okay, so basically you want a lift which is a function from z to y. Okay, okay, so this uh, basically, and this commutative diagram is commutative. Okay, so you will say this g tilde is lift of g via f or with respect to f. Okay, this is clear definition of lift.
Yes, sir.
Okay, so let us see one thing. So question is, does lift always exist? Okay, so this is the natural question. We will see the answer is not completely, I mean, the answer is no, but with some particular condition we can say it is yes. Okay, so so let us see. So the thing is, f says that y to x is covering, g says that z to x is holomorphic, okay, there exists g tilde from where to where. So from this g tilde is basically lift of g. So basically uh, the domain of g tilde is basically the domain of g only. Okay, so z to y, okay, such that f o g tilde is equals to g. Okay, such thing happens or not. Okay, so this is the question. So what we will do is, let fz is equals to e to the power z. Okay, basically f says that c to c star. So basically this is your y, this is your x, and gz is equals to z. Okay, g says that c star to c star. Okay, so if we say about whether this g tilde is continuous or not, okay, such continuous g tilde will exist or not, so that it satisfies this one. Okay, see here covering is already a continuous map and it is holomorphic. So basically, so in particular it is continuous. So whether g tilde, this continuous function, can exist or not. Okay, does such function exist? So let us see here. So basically we need g g tilde such that g. Okay, one such thing is gz is equals to log z. Okay, ln of mod z plus I into argument of z. Okay, so basically g tilde, g tilde is defined from c star to c. Okay, so basically we can say that we know that g tilde is not continuous on c star. Okay, so such continuity will not exist. Okay, but if you impose some extra condition, this will exist. Okay, basically for reference you can go through like this. This is the lifting of curves. Okay, for this you can basically refer to Conway. Let me write the reference. Covering space theory is there. So Conway. So Conway function of one variable. Conway functions of one. John B. Conway. Now let us look at the another concept, which is called the Little Picard theorem. Okay, so it says that if if an entire function if an entire function omits 2 points, omits two or more than 2 points, 2 points, then f is constant. Okay, so if I ask question, okay, does there exist a non-constant entire function such that uz is not equals to vz for all z belongs to C? Is it true? What would be your answer? Does there exist a non-constant entire function such that this holds? Can anyone tell me? Hello?
यस सर बट ये सिचुएशन में कंफ्यूजन है
This one?
इसमें मींस इस टाइप के क्वेश्चन ट्यूटोरियल में है ना तो वो आते नहीं थे
Okay, okay. So basically you see, if uz is not equals to vz, okay, means what type of, so basically your entire function is fz is equals to uz plus I vz, and you are saying you have to construct an entire function such that this happens. Okay, uz is not equals to vz, so what kind of points you will omit? Can your, like, can 1 plus
लाइन
I belongs to f of c? So 1 plus I doesn't belongs to f of c, isn't it?
यस सर y इक्वल टू x
Yeah, so basically x plus ix, sorry, this thing will not belongs to your range. Okay, okay, and your f is entire function. So by little Picard, it is constant, isn't it? Because cardinality of this is obviously greater than equals to 2. 1 plus I, you can also construct 2 plus, I mean 2I. Okay, similarly 3 plus 3I. So all these points doesn't belongs to f of c, isn't it? Hello?
यस सर
Yeah. So by little Picard, F is constant. Now you can solve the assignment problems. So if you change the uz is equals to a vz, then again you can apply the little Picard, okay, and this way you can solve the assignment problem. So this is done with the week 12 assignment. So we
सर
have question only
vz
on.
is not vz is not equal to 0 ऐसा है तो
Sorry.
vz is not equal to 0
Now can you read the
means
full statement?
there exists a non-constant entire function f equal to u plus iv such that vz is not equal to 0.
Entire function f equals
F
to u
equal
plus iv such that
such that vz is not equal to 0.
so vz is never 0.
Yes.
Okay, so basically this question is from the current assignment.
यस सर बट 2 दिन से मैं सोच रही हूँ बट ये आइडिया तो आज मुझे अभी आया इसमें से.
Okay, but this is different idea. Whether this you can use with this one, you have to check.
So
You
y
want
is
to,
not equal to 0 होगा ना सर. Y is not equal to 0
yeah,
means
y cannot be 0.
हाँ. So
Then
फिर आगे क्या करेंगे? y is not equal to 0 तो x plus iy means y 0 नहीं है तो एक ही पॉइंट ओमिट होगा ना.
which point?
0.
So it is asking there exists a non-constant entire function such that vz is always non-zero. Okay, so you collect all those points. So what kind of points it will omit? Can f have x plus I0 kind of points belongs to FC? Is it possible? Whether this thing is possible?
Yes sir.
This thing is possible? I am saying that suppose there exists such f, okay, then this set of real line, okay, is sorry, this, so you take any x belongs to the set of real line x, does x belongs to f of c? This is my question.
No sir because vz is not 0.
Yeah, vz is not 0. So basically this whole real line, if x belongs to r, then x doesn't belongs to f of c. Okay, so f omits all these points. Okay, so by little Picard, little Picard it has to be,
Constant.
yeah. So means, is it clear to you? Now you can understand this one.
Yes sir.
Okay, okay, nice. So this is done with the, so we are done with the week 12 assignment. If you have any doubt, you can ask. So this is basically the last week, week 12. So if you have any doubt, you can ask. I've also given the reference where you can see more about this covering spaces. Okay. Also, you can see the Mankar's book, Topology.
सर और एक डाउट है.
Yeah, topology. There are also covering space theory is there. Okay. Yes. Anything else?
Yes sir. f and g are entire functions
Hmm.
such that
Okay. F comma G entire.
function such that
हम्म
e raised to zz प्लस सर नीचे है e raised to fz प्लस e raised to zz equal to 1. Then f and g are constant functions.
Okay, this is the so this is the present assignment, like this week. I mean, this year's
Yes.
assignment.
Yes.
Okay, so basically, I am not allowed to tell about this those assignments. But so, what are the method you are using in this one? Any idea?
सर ये लिटिल पिकर्ड मेथड यूज कर सकते हैं.
How?
ये सभी क्वेश्चंस इसी से रिलेटेड है इसलिए मैं बोल रही
So, do you have any example where this satisfies? Okay, for f and g, if f and g is constant, this will hold, no problem. But other than constant function, do you have any example where this holds?
Take f of z is equal to I is z and g of z is equal to minus I is z.
Sorry,
F of z is equal to I is z,
I into z
g of z is equal to minus I is z.
minus,
I is z.
okay, then so e to the power iz plus 1 upon e to the power iz, that is satisfies 1, e to the power 2 iz plus 1 upon e to the power. I don't think it satisfies this equation, isn't it?
Yes, sir.
Yeah, this will not satisfy this equation. This one. So I'm not so I cannot basically comment on this one because this is the this year's assignment and you have to submit this one. But anyhow, you guys can email me and regarding your questions, I will write my email ID. Maybe you all know with this one.
बट सर गिव सम आइडिया व्हिच मेथड इज यूज्ड.
So this is week 12 assignment.
यस.
So the content of week 12 is same, isn't it? I mean, like what I'm asking is content of week 12 is same as the previous years, na? So the most probably little Picard will work. You have to use some little Picard or anything. I think so. I don't know right now. Okay, maybe little Picard will help. Okay.
ओके सर.
If you can see this one, so this will be basically e to the power fz is equals to 1 minus e to the power gz. Okay. F and g are entire. Okay, now one have to look at this one. Okay, so one have to look something at this one. These all are entire. So basically, it is 1 minus e to the power zz. Okay. So basically, it is saying e to the power fz is nothing but the you can translate it by 1 e to the power gz, isn't it? This only your translation you are doing, yeah? 1 plus something. Okay, so this is it, 1 plus gj. Ef and g must have to be constant, I think. You look into this question. This is a present assignment, and try to use uh, little precard somehow, because that is the only content you know right now. Okay. And if I'm writing my email address, you guys can ask me if you have any doubt. Okay. So I've written my email in chat box. You can contact this one. So any other thing? After this, you guys have to give exams, if I am correct, isn't it?
Yes, sir.
Okay. Okay. So yeah. Yes, that's anything.
Happy Diwali, sir.
Yeah, yeah. Happy Diwali. Thank you. Happy Diwali to everyone. So good luck for your exams. And if you have no doubt, I will just close this session.
Thank you, sir.
Okay. Okay. Thank you.
Wish you happy Diwali.
सर बहुत बहुत धन्यवाद सर.
Yeah, yeah. Thank you. Thank you so much. Dhanyawad. So I will just close the session. Okay.